Welcome to Mbuya Parent School and Kindergarten, situated in Kampala City with modern, well-equipped facilities plus extensive playing fields and amenities. Mbuya Parent School believes that a better future lies where children know how to find and create balances in themselves and the world around them. This explains our fusion of academic subjects and co-curricular activities. There are many opportunities presented to them to flourish both in and outside the classroom.
I want to become a president when I grow up.
I want to be a pilot.
I will be the best fashion designer.
Mbuya Parent School, the sky is our limit.
My name is Teacher Salim Bubakar. Here to take you through mathematics, but before that, allow me to share with you a few hints. In the very first place, we are in the coronavirus. It is really a pandemic, it is global. It is my humble appeal to everyone, my learners and whoever is viewing, please take precautions. Wash your hands daily. Sanitize, as you see with your teacher here, have a sanitizer. It's very perfect. You are advised to regularly wash your hands, keep the social distance, not forgetting the hugging. It's not proper to keep hugging in this pandemic. Without wasting much time, my learners and whoever is viewing me this time, allow me to take you through the lesson of the day, and that is mathematics. In particular, we're going to look at length, mass, and capacity. And basically, as I said, length, mass, and capacity is quite longer. You're looking at a length in particular. Length in particular is still quite longer because we look at length of various polygons. In this case, we're only looking at quadrilaterals. And those who were moving with me previously, we defined what quadrilaterals are. Just to take you a little back, quadrilaterals, these are four-sided polygons. Under those four-sided polygons, we are picking one, and that is a rhombus. And we are briefly going to look at some properties of a rhombus before we actually come to its area and a perimeter as well. Now we need to know what a rhombus is. In the very first place, a rhombus, this is a four-sided polygon. We looked at a number of four-sided polygons, and one of them was a rhombus. You know the rest, the parallelogram, the kite, the trapezium, name them. Perhaps one of the properties of this figure, the one you see at the chalkboard, is actually having all sides equal. It is a four-sided polygon having all sides are equal. And this rhombus you see, it is actually having two lines of folding symmetry. And those lines of folding symmetry, they bisect at right angles. As you see your teacher, these are the lines. They are diagonal. They are diagonal as you can see them. As you can see them. My learners, I know you're following me. These are the lines of folding symmetry. They are two, and they are diagonal. We said they meet or they bisect at right angles. They bisect at right angles, giving us a total of four right angles. So this figure has got four right angles. That's not enough. This rhombus, it has got opposite angles are equal. We look at this angle here and this angle here, they're actually equal. Giving an example, if this angle is actually 60, you'll get to realize that this angle will be 60. If this angle is 120, this angle too will be 120. Those are some of the properties of this figure that we are going to look at this morning. Briefly, we're looking at area and perimeter of a rhombus. I expect all my learners by the end of this lesson 1 to have defined what a rhombus is, 2 to define area, 3 to define perimeter, and lastly to get area and perimeter of a rhombus. Now area, to begin with, area is just a size of an object. Give an example. If this is my book and you're being told to get area of this book, just need to measure along the length, looking at my book. Along the length, it is measuring 20. Along the width, I know you're also doing it. Along the width, it is measuring 10. meaning that the size of this book will actually be 20, they are centimeters, 20 and 10, giving us a total of actually 200 square centimeters. That's not the case. The case in this case is actually this rhombus here. Now, area of a rhombus is gotten from the formula. We've got actually a variety I want to share with you. One of them, if you want to get area of a rhombus, we have to say a half times diagonal 1 times diagonal 2. It is also very important for us to tell these diagonals. In this rhombus, it has actually got two diagonals. One, we have the major diagonal, and then the other one is the minor diagonal. At the longer diagonal, you can see the long diagonal from this vertex to the other is what we call the major diagonal. And this smaller one from this vertex to this one here is what the minor diagonal. So major diagonal is given D1, diagonal 1, whereas the minor diagonal is given D2, not standing for diameter, but actually standing for diagonal 2. If you don't want to use that one, I said you may find this one a little hard for you. You may also decide to say area of a rhombus is actually diagonal 1 times diagonal 2 divided by 2. Diagonal 1 being your major, diagonal 2 being your minor, all divided by 2. That will give you the area of that figure, which is a rhombus. And then the last formula, we can have as many formula as we wish. Last we can say area of a rhombus is actually a half times base times height times 4. Briefly, I'll explain why do we use this formula. We've seen it previously. This formula is used for getting area of a triangle. Now we are saying that in this rhombus, we've actually got 4 triangles. We've got 1, 2, 3, and 4. And these 4 triangles, all of them are right angles, and actually they are right-angled triangle, and they are all equal. So if we get the area of one triangle and we multiply by 4, we shall be getting the area of the whole figure. Remember, this is a rhombus, and it is made of these 4 right-angled triangles that we are all viewing here. I want to go direct to our question. My learners. And here is my excuse me. I know you'll be able to see it. Yes, I know you are all able to see it. As I said earlier on, we are looking at area and the perimeter of the rhombus. We've got to know how this figure look like. Perhaps we're looking at the area. We've said not area is equal to a half times diagonal 1 times diagonal 2, or you can say area is equal to a half times base times height multiplied by the 4 triangles made or found in this rhombus. Back to the question. Question number 1, we've gotten 3 questions. I'm going to help you go through the very first question, and then these 2 questions, you'll be doing them as your activity. You'll send them to the teacher. I will mark them and then forward the responses. Question number 1, a BCD below is a rhombus whose diagonals AC and BD are 6 centimeters and 12 centimeters respectively, in that order. So this is our figure, the rhombus. We've seen that diagonal AC, which is our major diagonal, or the long diagonal, is measuring 16 centimeters, whereas diagonal BD, which is our diagonal 2, or the minor diagonal, is measuring 12 centimeters. So we've been requested to find the area of this figure. We're basically going to pick one formula out of the 3 and then use that one. I wish to use the very first formula. The very first formula we stated, it is a half times diagonal 1 times diagonal 2. That's the very first formula we've started with, and I wish to use that one to find the area of this figure class. Right? We've seen area is equal to a half times diagonal 1. We've said diagonal 1 is our major diagonal, and the major diagonal is the longer diagonal, our longer diagonal is 16 centimeters. So times 16 centimeters times diagonal 2, which is the minor diagonal, and it is diagonal BD, measuring 12 centimeters, times 12 centimeters. We go ahead and reduce. By 2 it is a 1, by 2 it is 8. So we shall have area giving us 8 centimeters times 12 centimeters. So multiplying centimeter times centimeter, that will give you a centimeter squared. Then we can multiply, as I said, horizontally. We have 8 times 2. Class 8 times 2 gives us 16. We shall write a 6 and regroup a 1. So we have 8 times 1. 8 times 1 gives us 8, plus 1 gives us 9. So the area of this figure shall actually be 96 square centimeters. Class, if you forget the units, you lose the mark. These are very, very important. If you just give 96 square centimeter, I must tell you your answer is wrong. So be very careful when writing down the units. So also carry some sense for purposes of being too organized to get your ruler and underline your answer. I wish you double underline your answer. My dear learners, before we go to part B, I want to emphasize the point of underlining our answers. It is a very, very crucial point. After you've gotten your answer, please get a ruler. Don't use the free hands. Get a ruler and double underline the answer, just as your teacher has done here. It gives an opportunity to whoever is going to mark you to see exactly where the answer is. Going back to part B of the question, part B is requiring us to get the length of this polygon AB. I said, getting the length of this AB, we need to go back to P6. In P6, we looked at the application of Pythagoras theorem. And I remember making it very clear that Pythagoras theorem deals with the right-angled triangles. So looking at our polygon here, as I said from the beginning, these two diagonals bisect it at right angles, giving us a total of 4 right angles. So we shall only need one right angle, which is where basically our line AB is lying. So we shall identify that center as point O in order to have our line OB, our line OA, and of course our major line that we are looking for, and that is line AB. And as you can see, I've shaded this right angle triangle to show that clear difference where our line AB is lying from other lines, because we've got so many lines here. So I want us to extract this line. The reason as why we extract this right angled triangle is actually to have the proper application of the Pythagoras. So we are going to extract this right angled triangle. Class, and when extracting, please, I beg of you, start with the line AB. Start with the line AB, and this is our line AB. Please use a ruler always. I beg of you, use a ruler always. This is our A, and this is our B. That's the line we are looking for. So we need to come up with the right-angled triangle, just as it is. I want to bring it the way it is, class. So we can see it here. We can see it here. And we can see it here. Never mind. Never mind. What is very, very important, class, is that symbol of the right-angled triangle. It's very, very important because, as we said, Pythagoras theorem deals with right-angled triangles. So we have our AB, we have our O. We have our O. So we have AB, we have OB, and we have OA. But we need AB. Before we get AB, class, we must be having OB and OA. Back to our figure. We have seen that the major diagonal is actually measuring 16 centimeters. So a half of 16 shall give us 8, meaning that O and A, which is equal to O and C, it is equal to 80 centimeters. So this gives us 80 centimeters. Such that when you add 8 plus 8, you'll go back to 16, which is our major diagonal. Now we need O and B. We've seen that the minor diagonal B and D is 12 centimeters. So a half of this will be 6, meaning that from B to O is 6, and O to D is 6, a total of 12. So we have our 60 centimeters there. So from that point, we can now apply our Pythagoras theorem. Back in P6, we say this adjacent is given letter A, the opposite is given letter B, and the longer side, which at one point you'll term it as the hypotenuse, is given letter C. So we said in the application of Pythagoras theorem class, those who should remember, those who don't remember, please, you can copy it from here. The square of A plus the square of B is equal to the square of C. The square of A plus the square of B is equal to the square of C. Now the next step is substituting in. We've got to know that our A is 60 centimeters. That is now squared because we are squaring it, plus our B, which is 80 centimeters. It is squared. I have a reason as why I'm putting these two in a bracket class. And please, I'm emphasizing the brackets. Is equal to the square of C. Now, after that, we go ahead and expand. We've stated down the formula. We've substituted in. We go to the next step, which is now expanding. So we shall have 6 centimeters times 6 centimeters plus 8 centimeters times 8 centimeters plus giving us the square of C. Giving us the square of C. Class, I hope you are all there. I want to take you back here. We've ended at 6 times 6. 6 times 6, class, we shall get a 36 square centimeters plus 8 times 8 centimeters times 8 centimeters. Class, we shall get 64 square centimeters, giving us the square of C. Now addition here comes in. Class, 36 plus 64 shall give us 100 square centimeters, giving us our square of C, or C raised to, you can also see squared. Now here we go back to square root. It is very important, members, to apply the square root symbol. Go ahead and rewrite that statement before applying the square root symbol. If you don't apply the square root symbol, please, you lose a mark. It is very important for you to apply the square root symbol. Class, what's the square root of 100? I know you must have answered there. With me, the answer is 10 centimeters, giving us C. It is now no longer C squared because we've gotten to know the square root here. So our C is 10 centimeters. Class, we don't need the C. What do we need? We need the length A and B. So therefore, our length A and B is equal to 10 centimeters. As I said, I want to emphasize, after you have gotten your answer, please get a ruler and double underline. The reason is very clear. The examiner will not hassle looking for your answers. Hope, class, you with me? I want us to go to the very last part, and the very last part is now getting the perimeter of the rhombus A, B, C, and D. I want to set it clearly the way it is. Work out the perimeter of the rhombus A, B, C, and D. Back to my book I used the earlier on class. You can also get your book. I measured with you. The length of this book was measuring 20 centimeters. I still have it here. And then the width of this book was measuring 10 centimeters. So meaning that my book here, it is measuring 20 by 10. I want us to briefly use this book here to help us know how best can we get the perimeter of any given figure. In the very first place, we need to define what perimeter is. Perimeter, class, is just the total distance around whatever figure being given. It may be circular. We shall look at those ones with the circumference. But here we are dealing with the quadrilaterals. So the distance around this figure here is actually what we call the perimeter. So giving an example, my length is measuring 20. This one is measuring 10, 20, and 10. Class, when we sum up the 20 plus 10, that gives us 30, plus 20, that gives us 50, plus this 10 here, that gives us 60. Meaning that the distance around my book is actually 60 centimeters. I want us to borrow that idea and apply it here. We want to find the area, and not the area, class. We want to find the perimeter of this figure, which is A, B, C, and D. Yes, class, I want to summarize with part C, and I'd given a clear example of this book where we all measure together and we came up with the 60 centimeter as the distance around this book, which also termed as perimeter. They can ask in this way, find the distance around or find the perimeter. I want us by this idea and use it to find the perimeter or the distance around this polygon, which is actually a rhombus. We've got to know that AB only is 10 centimeters. AB only is 10 centimeters. But from the properties we gave, the properties of this polygon, we've got to know that all the sides are equal. So if this is 10 centimeters, class, if this is 10 centimeters, it will automatically mean this is 10, this is 10, and this is 10. So back to this book, we said we added distance around along the length, along the width, along this length here, and along this width here. We are going to do the same here. Perimeter, class, as I said, and I want to emphasize, is the distance around the figure. So summing up the length, summing up the 10, the 10, and the 10, and the 10 shall automatically give us the perimeter. I want us back here. That is our part C, which is perimeter. We've seen that perimeter is the distance around the figure, and we're seeing that this figure has got 4 sides. We can say side 1 plus the second side plus the third side plus the fourth side, because it has got 4 sides, all are equal, shall give us the perimeter of this figure here. Now that's the first step. The first step, it is stating the formula. Then when done with testing the formula, please go ahead and substitute in. Our first side is measuring 10 centimeters. Since it is a rhombus, all sides are equal, so all sides are measuring 10 centimeters, plus 10 centimeters, class plus 10 centimeters. We can add in pairs. We can have the 10 plus 10, class 10 plus 10, that will give us 20 centimeters, plus 10 plus 10, that will give us another 20 centimeters. So we have perimeter equaling to 20 plus 20, which will give us 40 centimeters in this case. After that, please, I want to emphasize the point of underlining your answers. Get a ruler, double underline your answers. It is very, very important, and I will keep giving you reasons why we have to do so. There are some candidates who do wish to say, teacher, but you've said that this polygon has got all the 4 sides equal. What if I say perimeter is equal to 4 sides times 1? Because all the sides are equal. Class, I want to say you are 100% correct. You can say perimeter is equal to the 4 sides times the length of each side. We've gotten that the length of each side is actually 10 centimeters. So we shall finally get our perimeter as 40 centimeters. And that will be our final answer. Please do the same. Get a ruler and double underline. It's very important. The examiner will actually find no reason to say that I did not see the answer. At that point, you actually get all the marks. Class, as I summarize, we've looked at the area and perimeter of a rhombus. And I hope everyone out there at this time is able to define 1, area, 2, perimeter, and then lastly, the polygon we are looking at. The polygon is a rhombus. Then secondly, we must be in the right position at whatever level to find the area of any given rhombus, to find the length for whatever rhombus we've been given, and lastly, to find the perimeter of whatever figure, as long as it is in line with the rhombus. However, we can also use this approach to find the perimeter of other figures. Class, I wish to request you kindly, answer for me question 2, answer for me question 3, rightly following the procedures and the steps, and then forward your answers on my WhatsApp number. Please, I promise you I will mark it and forward the responses. I wish you the best. Please stay safe, stay home, sanitize,